Okay, today we're getting deeper and deeper into it. And so um, thus far, we talked about what a lesson plan is. And I'm just going to bring up a few things just to, you know, to remind us of what that is about. And so I'm just going to share a screen and I'm going to bring up these guys. Oh my God, these are the standards. Remember we mentioned these about about 2 weeks ago. And so it's convoluted, but the most important ones are in yellow. That's what you have to copy. You have to copy one or two of these. Don't go crazy. Don't spend hours. Just pick out one that is connected. You might say, oh, Dr. D, it's not really that connected. Well, tangentially, tangentially, that's good. Okay. So pick out one and just copy. Just don't write PPS1-1. Write out this black thing. Okay. I don't care about the red underneath that, just the black in bold sentence. All right. So once again, these are our standards. The blue stuff is the verb, science as a verb. These are like the methods. And then you have the orange is the science as a noun. And these are our concepts. They call them core ideas. And then cross-cutting concepts, these are the ones that kind of link all sciences together. And they're the big picture. All right. So that's that. We did that. I'm going to close that one. And we also did, ooh, this guy. This is not great. We don't like this. Let's say, let me just put a academic language and science. Boo, hiss. Okay. Remember vocabulary, right? That is important though. I would, if I, when I become a full-time teacher and I had to do my lesson plans, I'd make them one page. I cut out all academic language except vocabulary because that's a really key thing. And it's been with us before academic language and it will be with us afterwards. So remember, they're the concept, the nouns. There's also, they could be a non-science meaning. So you want to be cognizant of that because kids will get mixed up. What term are you using? And then there's the most important thing is misconceptions. And this is like, there's been misconceptions research for decades now. And so you could actually Google misconception of the concept, plate tectonics, and you can look that up. And they might say, hey, students are going to have problems with this and this. You want to list that because you want to address that point blank. You want to address that in your class. Okay. So that's this is the vocabulary. And then we had like I used like chemical coefficient, if we remember, as an example. We have science meaning, non-science meaning. Oh, there's the math coefficient, and then misconception. All right. Language function. That's another word. That's a phrase for what? What does that refer to again, you guys? I can't see hands to speak up. What does that refer to? Language function. It's a fancy name for?
Verbs.
Yeah, excellent. Verbs. So you have verbs like, and so the verbs are like, they can be very specific. Like I would say titrate. If you've taken any chemistry classes, and if you remember that far back, maybe to high school that you did a titration, titrate is a very specific verb, right? But most in science, you don't have a lot of those per se. You kind of have like tabulate, organize, analyze. So this would be something that you would put in your little section called language function. Um, I balance the chemical equation. That's very specific to chemistry. So that's something that you should be writing down in this section. Discourse. Discourse is another word for writing or speaking. So I always use this phrase, and I don't have it in my book in some of my lesson plans, and I'm going to change that. But I like that phrase where you say, my students will be, my students will write like scientists when they fill in the blank. My students will write like scientists when they balance a chemical equation. And then there's another part of discourse, which is speaking. My students will speak like scientists when they fill it in, when they verbally explain a chemical equation. Okay, so discourse has two things. And I want you to get full credit on this EdTPA exam. So I would add those two things in. And then the last one is your student, how scientists talk, how scientists write. Okay, syntax. Syntax, and this is the strange one, rules of the writing, rules of the speaking. Once again, we don't have a lot of rules for speaking unless you're doing a poster presentation, but there are rules for writing. So, like writing in a chemical equation, you balance it on each side. That's a writing rule, okay? And so I would definitely put that down. Like my students will obey the rules of writing when they, and then fill it in. Okay, so those are the four things I did really quickly. It's something that you have to know to pass this exam. So I'm going to require this as part of any lesson plan that I give you, with the exception of science and society. In the science, if you're taking my science and society class, if you're not taking it or haven't taken it, or if you will take it, you have to put vocabulary in there and non-science meaning and misconception. So you have to kind of like do the first, you have to do the first row of those four and leave out the other three in science and society. But in my classes, all my methods 1, method 2, and student teaching, I want to see this, because then you have to prove to me that you got this down, that you're going to be okay on the exam. Okay, that was my little blitzkrieg until like we're done. We're done with that. Was the lesson plan. These are the two pieces that are the most difficult. So let's get out of that and let's start looking at the opening. So what I did was I asked you guys to, we talked last time about the opening. What are the four pieces of the opening of a lesson? And one is right in front of your face. One you're looking at.
Having an aim on the board.
Yep. Okay. So you have the aim, and let's pretend that the coronavirus is over. You have a whiteboard. You might have a blackboard, and you'd have the aim right in the middle. That's the first part, and we're looking at the beginning. So you have the aim. What do you think you have on the left? What do you have? What do you think
The do now.
Yeah, right. You have a do now, and the do now is a bridge from yesterday, perhaps, or it could be a bridge to today. It could be something about the lesson that you're presenting, or it could be a recap of yesterday's lesson. And it should be, you're trying to be motivational. Once students answer the do now, you can erase it and have that room. What about on the far right? What would you put on the opposite end of the do now?
The objectives for that day's class.
You know what? The objectives are going to be wrapped up into the aim. I know, Dimitri, you're gonna have your objectives written on your lesson plan, but the aim is pretty much going to encapsulate those ideas. So what would you put all the way to the right?
Homework.
Yeah, and why do you put the homework on the board in the very beginning?
So that the students don't miss it.
Exactly. When the bell rings, you're like, oh, I forgot to tell you guys, this is the homework. No, it's always in the same place at the very beginning of the lesson. Now, look, you guys might not be privileged enough to have this huge big board. You might go into a classroom where you have a small whiteboard. So you might have to use like elementary poster paper that has a little adhesive to the top, and you could stick it onto the side. Or you might have like a little mini whiteboard. Everyone is blessed with different board space. And at Hunter, I was really fortunate to have this huge wall of board space. And they took down this blackboard and they put up the same dimensions on a whiteboard. So that's really nice to have. But aim, do now, homework. And what is the last piece of the beginning? Remember this.
The motivational opening.
Right, the motivational opening. Remember that video that we saw? It was kind of old and hokey, and I like that educational music and the haircuts and all that. That was, remember this 1 inch, one person said, let's pretend to be 1 inch tall. And so that's the motivational opening. And you know what? That 1 inch kind of reminds me of that motivational opening, but it also reminds me to keep it short. You're keeping it a minute, 2 minutes. So let's check out one of my old students, this guy, Dan, excellent guy. And he's going to do a motivational opening. And I think it's about 2.5 minutes long.
Morning, class. I'm Dan Jimenez, and I am your earth science teacher for this semester. And I think that you are going to love earth science by the time we're finished here. What's this? Who can tell me what this is? It's a rock. Very good. Everyone gets an A for that one. Okay. A lot of crystals in there, right? What kind of crystal would you say that is? Quartz. Very good. Two A's for you today. Okay. So, you know what the rock? You know that it has large, pronounced crystals in it. Who can tell me what kind of rock this is? Yeah, in about maybe 2.5 minutes, you'll get an earth science reference table. Well, crystallization, very good, igneous. Okay, all the boring stuff is done. Huh. When you look at a rock, any rock, what do you think to yourself when you see the rock?
The texture, the color.
Texture, color, maybe what it's composed of. You can throw it through a window. No, not you. Okay. Well, okay, sure. The texture, its composition, right? And how about the age of the rock? You ever think about how old the rock is, right? Well, that's the most interesting part, in my opinion, is the age of the rock, because this here isn't any ordinary rock. Okay. What if I told you that this rock was hundreds of millions of years old? Okay. So think about this. This rock experienced the great continent of Pangaea. It saw the dinosaurs walk across the planet. It had seen the birth of trilobites, right? It probably had a few walk over it. And what else? Well, right now it hasn't seen anything because I want to introduce everyone to Stone G. Rockefeller. Igneous rock, time traveler. This one's for me.
Okay. So this is a motivational opening, and his little, his humor with the, putting eyes on rocks. It didn't take any time, but it's like, hey, I'm going to remember that lesson. All right. And like, the idea of like this stone has experienced this and this and this and this, it's memorable. Okay. And so that's, I think that's a decent motivational opening. Let's do another one from a student of mine called, her name is Nicole. So let's do her. Let's do that. Okay.
Hi, class. How's everybody doing? I know that we just came back from break, so some of us are still on spring break mode, but don't worry, we're going to ease into today's topic. Before we start, would anybody like to share what they did over spring break? And what did you do there? Very nice. Does anybody know what the Galapagos is famous for? Very good. Does anybody else have anything else they'd like to share? Did anybody do anything fun? Anybody at this table? What did you do?
London.
Ooh,
To the family. The wedding.
nice. How was the weather?
It was good.
It was good. Oh, summer.
Yeah.
Oh, nice. Oh, very good. Did you guys see each other?
Yeah.
Oh, okay. Does anybody have anything else? Do they have to get off their plate? Anything? No? Okay. So let's get, oh, did you? I'm sorry, I didn't see you. Go ahead.
To a Mets game and they actually won. So that's
Well, that's good. That's good. That's a rare occurrence. You're a Mets fan?
yeah,
I'm Yankees.
they've actually won 6 in a row. So
Yankees, that's right. Okay, so let's go back into school mode. And can I have someone read the do now? Maria. Okay, so I'll give you guys a few moments. Take a look at it. I know we just came back from break, so I will come around to see if we have to dust off the little brain cells a bit.
Okay, so what she's doing is, in the beginning is she came, she's teaching right after a break, and this little chit chat between you and the student, it's really important because it's like, you're interested in their lives, and you connect. This is an opportunity to connect, not in a profound way, but in a way that other teachers really don't do. And it's kind of like, having a smile, joking around, and then she's going to go into her do now. But let's see what she does after the do now. Okay. Let's see how she gets into her, let's say.
Almost done? You need a few more minutes or?
She's gonna go over the do now.
Okay, do you want to come to the board and just show me how carbon forms those bonds? Just the bonds. You don't have to draw a compound or. Mhm. Covalent. Does anybody know why it's covalent? Okay, and also because carbon shares the electron. They're not transferred like an ionic. Okay? Great. Can I now have someone read the aim for today? Sorry? Okay, so today we're going to talk about hydrocarbons. Now, just hearing the term hydrocarbon, can someone tell me what two elements they think make up hydrocarbons? Yes. Very good. Okay, we are going to come back to hydrocarbons, but I have a short story that I have to share with you guys. So, while Charmine and Alvina were in London, and while Robert was in the Galapagos, I was home at my house. Okay, I was practicing and getting ready for this activity. To give you a little backstory, my dad just got done having surgery about 3 months ago, and he's in recovery. So he couldn't do anything. He couldn't go outside. He was pretty much stationary. And for my dad, that's a terrible thing. He's always moving, always doing stuff. So he decides, I'm going to go downstairs in the basement. I'm going to clean up the clutter. I'm going to throw away all of his wife's things, which she was very upset about. So he's down there, and I hear a lot of noise going. I'm like, oh my God, let me go check on him. So I run downstairs to check on him. And I notice he's getting ready to chuck these. And all of a sudden, the apple falls on my head, the light bulb clicks, and you have to picture this, I dive and say, no, don't throw those out. I need them. So I catch them. And he's looking at me like I'm a crazy person. But I was happy because I had these. Have you guys seen these before? They look kind of familiar. Maybe a little bit. Okay. I'm going to pass them around. And I want you guys to look back at the aim. And maybe there's a word in the aim that can kind of describe what's going on in here. Now, this material is some type of gel-like material. So take a few moments. Then I'll put.
Okay. This is Nicole. This is the entire beginning. So she has some chit chat before, have students do the do now, then they read the aim, and then she does a motivational opening. Okay. And that's the beginning that I've been, we're just getting into last week. But this is a great example. And also this link, if you ever want to see it again, I also have one or two more of these motivational openings. They're not extraordinary, but they're enjoyable. And they kind of get your interest. You're like, I'm looking at this gel. I got to connect this to the aim. That's interesting. Like, what's going on here? So it kind of opens up, it kind of focuses the student, gets them interested in the lesson. And from there, she starts to develop it. And that's the middle of the lesson. So there's other people, there's other links in my book that go to these videos if you ever want to check them out. I think I might have one or two more motivational openings. Okay. Once again, simplicity. It doesn't have to be a big deal. Dan put some eyeballs on a rock, and then Nicole brought two like kind of fun gel type of things that she found. Okay. And so once again, simplicity and something short. Okay, now let's kind of go into the middle. But before we do that, since we're thinking about maybe let's see, yeah, maybe we'll go right into the middle. So let's look at the book. Okay, so let's see what page number this is on. This is on 91, all right? And so I'm getting a lot of students work in terms of their questions for the first 50 or so pages. And it's a story, we're gonna talk about it. I don't know exactly when, but we will talk about it. The most important thing is kind of getting into like, how do we teach this lesson? And so this is on page 91. So really definitely try to read the rest of the book. And I think it will make more sense when I put pages up. And so this is the first page. It's called Flex It. And so right now we don't really know why it's called Flex It, but flex means flexible, and then I means inquiry, and then T means teaching. So it's kind of like this idea of flexible inquiry teaching. Right now we don't really know what that means, but we will. Okay. And so here in the very beginning, you have these, this is what we did right here. Okay. We did the do now, the aim, the homework. Students read the do now, maybe attendance is taken or you're setting stuff up. And then the anticipatory opening could be called a motivational opening, anticipatory opening. That's what we got. That's the beginning. Okay. The aim is elicited or surprise, so that should be included too. Okay. So that's the beginning. Now, what is the middle? What is the next section that we're going to be talking about? And that's going to be about like the experiment. So what we're trying to do is we're trying to do an experiment with the students that answers a question. So inquiry is going to be focused on hands-on activity. It's a student-centered instructional strategy. And so the middle begins with modeling the procedure. So modeling the procedure, you're basically going to, you're not going, and this is really important, you're not going to pass out the materials. Not yet. You're going to get maybe a beaker. You have two beakers in front of you, and they both have colorless liquids. And you're going to say, well, you're going to measure out certain solution A and a certain amount of solution B, and you're going to pour them. And when you pour them, it's going to turn a beautiful blue. What is wrong with that model? What is wrong with that procedure as a teacher? There's something fundamentally wrong with that.
You're basically like dictating everything that's going to happen, not asking any questions, and just, students have almost no motivation to even do it because they know what's going to happen and all the steps and everything.
Well, the steps are important, but they know what's going to happen. You're telling them it's going to turn blue, and it could just be this beautiful blue, but you just took out the surprise. It's almost like saying, "Oh, here, happy birthday. Here's a gift." Yeah, it's a TV. Okay, and they might be happy it's a TV, but you gotta give the surprise away. Let them open it. So the idea here is, I got solution A, I got solution B, and I want you to measure out the liquids, and I want you to pour A into B, but you don't show them, especially if it's a dramatic or sudden change, or it's some sort of surprise to it. You don't do that. Okay. You might have like maybe a dozen procedural steps. So what you want to do is you might want to model the first 3 steps, have everybody do those first 3 steps, and then you model 4, 5, and 6, let everyone do it, and then you model the rest of it. Okay. But normally you really want to keep a procedure very simple. The more convoluted a procedure is, I would say that's, for the higher grades. So in middle school, I want to kind of keep this procedure very simple and then get more sophisticated as you get on. As a 12th grader, you might have like 15 steps. So you chunk it. So you're going to model it. It means like you might ask a student, come up to the board, come up with me and help me, help me do this. And maybe you're using a tape measure. And so you want to like, let's practice measuring, because if you don't practice measuring, the data could be pretty bad when they actually do the experiment. So if they're doing anything, they might have to practice that procedure. You might want that student to come up and actually do the first trial. And the first trial, it might be like, sending a go-kart down a ramp and you're going to measure the velocity. There's no surprise there. Let them do it. Because you don't really know, like, you don't know the rest of the experiment, which is you're going to compare different surfaces and see how that affects velocity. Or you might do velocity and then you might calculate acceleration and compare and contrast. So letting the car go down, yeah, you're showing them that, but you want to show them so that they get good data. Okay. You really want them to get overwhelming data. That's what I kind of call it, so that they see the pattern. So when they interpret the pattern, they're able to answer the aim. Okay. Doctor, you might say, Dr. D, but what about, like, making their own procedure and letting them make mistakes and kind of figuring it out? Okay. I want to bring up this form. Let's see. I want to bring up this form. And this is like, it's called, see the far right, it says levels of inquiry. When the teacher asks the question, and the teacher devises the procedure, and the teacher collects the data, and the teacher explains the data, you got a 0 there, not inquiry. Now, what about if the teacher asks the question, the teacher devises the procedure, the student collects the data and explains it? That's why I remember inquiry, it's like evidence and explanation. Collecting data, that's the evidence. Explaining data, that's explanation. Ooh, we got inquiry, folks. But this is the simplest inquiry that I'm teaching you. I'm teaching you how to do an inquiry experiment within 45 minutes, and it's difficult. It's challenging. In my other class, there's a class called 660. I don't know if you're aware of it. If you take you're going to be taking it with me. That's where I get into the idea of inquiry as project, inquiry as multiple days. Now, everyone, if you're a chemist, a chemist, earth scientist, or physicist, you're going to be in my class. For some reason, bio a few years ago put another class in its place. I wasn't teaching the course at the time, but now I am. I kind of revamped the entire thing. And so if you're in my class, you're going to learn how to do an inquiry experiment over like a week, over 3 days, 4 days. And what we're going to do is, like, you're saying, well, what's the difference? It's about rigor. So what I'm trying to do in 660 is I'm going to try to make you a really good experimentalist. This is what I mean by this. A lot of us, I can't say, like, I have a master's in chemistry, and I might say, well, I'm a chemist, but I'm not really a chemist. I'm not really doing chemistry, in a professional lab day after day. I'm not doing that. I don't have a PhD in chemistry. I'm not doing cutting edge research. Most of us fit into that category. I got a bachelor's in physics. I see myself as a physics person. I kind of call myself more of a chemical educator. You might call yourself a physics educator, a biology educator, but we're really not biologists. But guess what? We can become good experimentalists if we know certain techniques that I am sure you do not know. Okay. So I would say in the last 2 or 3 years, I've been working in this subject area about the idea of how to build confidence and deal with uncertainty. I'm going to mention this over and over, but those 2 terms are really important. And the idea that what is rigor and how can you be rigorous and teach rigor? And I'll tell you, folks, there's almost no books on it. People aren't doing it in schools because it takes more time. But my feeling is that's what makes science special, because they are rigorous. It's a rigorous enterprise. What we do is basically teach kids how to, like, go through a basic method, starting with hypothesis and ending with conclusion. And in between, there's a graph or so. That's about it. And that's cool, right? And what I'm teaching you is decent. And I'm teaching you for a practical reason, for time. I know what you're up against. I know it's a survey course. You're doing all these different units. You have a limited time. I need you to be able to do an experiment in one day. But if you want to be a good experimentalist and you really want to teach, teach other kids, your students, how to become a good experimentalist, 660 is where it's at. And that's what I'm delving into. And that's after doing this for 25 years. I finally really realized that it's a balance. It's two things. It's about inquiry, but inquiry, low inquiry, which is level 1, and it's high inquiry, level 3. So check out what level 3 would be. It would be the student asks the question. The student devises the procedure. The student collects data. Sends data. And that is like level 4, the highest level. Normally, this is for student fairs, like science fairs. Okay, research, but I like this one too. I love 3 and 4. I love 3 and 4. And so we're not going to be doing 3 and 4 in this class, but in 660, we're going to do it. And so I'm hoping, and I've only taken this course over like I don't know, a year or two ago, but I'm writing I'm writing these 2 textbooks for it. I'm really into it. And I really think if you have both, it's incredible. So we have some questions. Once again, I can't see everybody. So Katerina, go ahead.
Hi, good evening. I just want to understand, can you give an example of the last 2 inquiry lessons?
Okay.
An example, especially for the last one, just how would it look like in simple
Okay,
words?
here's a simple one that everyone kind of knows, like density. I might give some objects and I'll say, find the density. And so it would be like right over here, level 3, I'm giving the aim, I'm giving them the question. I want you to find the density. Now they have to come up with how to do that. And they have to collect data and they have to explain it. And so how to be rigorous in this process and how to scaffold and guide them, that's what that course is about. Okay. And so, it's going to take up more time, right? It's going to
I'm
take up a
sorry,
lot more time.
I have another question. For that course, I just checked my program. I think it's not included because I'm a
I know.
bioscience, so I think it's only for chemistry. Could you recommend like any textbooks or any useful links maybe for that course?
Well, I'm writing the textbooks for the textbook for the course, and I could definitely give it to you and you can check it out. Also, if anyone wants to audit it, just kind of like sit in and see what it's about, you like it in terms of just you don't really have to take it. It's given next semester on Fridays, or I think it starts at like 4 o'clock or something, 4 p.m. And it's like 3 or 4 hours long. And so it's going to be like, it's not going to be me talking. It's going to be like doing experiments. And we're going to be doing like, think about like how to do a simple experiment, like doing density, but rigorous. How do you do that? Well, hell, you know what? You do a lot more repetitions. Our first experiment in this class is from Michael Faraday, who's like an amazing chemist in the old days. And here's a great story with him because he was a bookbinder. He's apprentice. He's young, and being making books, you have to worry about the embossing and the material and the stitching. It's a whole big thing back in the time that he was doing it. And so he went to this guy. He was kind of like interested. He started reading all the books that this publisher made. He was working for a publisher. He's reading all these books. And he's like, whoa, this is really cool stuff, especially the science stuff. So he goes to this talk about like, popularization about science by this guy, Humphrey Davies in England. And, people are like, this is like, there's no internet and there's no, like, you only know knowledge through books or someone gives us a talk about it. And so he went to it, he loved it. And he went back to the successive talks. There was a multiple like series, and he wrote down every single thing that Humphrey Davies said, and he drew pictures, and he made a little book. He made a little book, and he sent it to Humphrey Davies, who was like, in the Royal Society and all that stuff. He says, hey, I would love to work with you, and Humphrey Davies, says, I'm sorry, but there's really no openings. But after a few months, there was a big brawl happened. There was some fight or something happened. I'm getting this from like this historian of science, like some big fight happened, and one of Humphrey Davies' assistants got fired. And so he called up Faraday and said, I don't even know if they had phones. I guess he sent a message by horse. So Faraday gets this message, said, hey, come on into and work for my lab. And so he works in the lab, he does stuff, and then they do like a European tour for 19 months. And he goes with Davies, and he goes around, he talks all about science, and he's helping them. Faraday becomes one of the biggest chemists ever in the history of chemistry. And he from humble beginnings, when such a the class system in England was brutal. And he rose up to be an amazing chemist. And so the first experiment we do in that class is we look at a candle. We look at a candle and we have to make 100 observations of a candle. Okay. And so it's the deep dive. It's the deep dive into the physical world. And that's what the course is about. My first experiment that I ever did, my first chemistry experiment that I ever did in high school was looking at that candle. And that's the only experiment I remember. And it was like otherworldly. It was like an experience that I never had in my life before, looking at something so closely. And that's what makes science special. So anyway, that course is about that. But this course is that other hand. It's like how to do science, an experiment like that in 45 minutes. The other one I'm going to teach you how to do science in a week. Okay. So it's really radically different. But as you see, I'm into this stuff. I kind of love it. And I really believe that you guys can be really good experimentalists by knowing generalizable techniques. And like one of them is making a graph. You know how to make a graph. That's not going to be one of the techniques I'm going to show you. You're going to make graphs, but we kind of got that down. There's other things that you can do that are pretty straightforward that you kind of like never heard of. Okay. I'm just going to give you a brief example. Overlap. When you plot something and you put error bars on it, you're very, very interested in overlap. Do the error bars overlap from one point to another? Okay. So the concept of overlap is critical to have cause and effect relationships. So if data point 1 overlaps with data point 2, right? You can't tell them tell the difference between those. Therefore, the new cause for data point 2, that effect, you can't differentiate the cause and effect from data point 1 to data point 2. You can't claim that there's a linear relationship. That's a big deal. So the idea of overlap is something that's simple, straightforward, but you and I are never taught about that. Okay. Some of you might, I know there's some of you who might have a doctorate in science. You might have looked at that, but for most people, that's never done. So those are the kind of things that we're going to do. And then, so here in the middle here, you might have like teacher. You might have, let's see. You might have, sometimes you could have, yeah, I think I'm kind of messing that up. I probably should have just something like this. I'm just looking at all the combinations here. Okay, so in the first row, it's all the teacher and zero inquiry. And the second one, the teacher asks a question, devises a procedure, student collects and explains, and then we have a little bit more of the student, and then we have all student. So we're going to be probably going for 2 and 3 in the next course. Sorry about that. Okay, so let's go back to the body of the lesson, right? So the body of the lesson is going to be procedure, collecting data, and explaining data. Okay, that's kind of like the body that we're going to be focusing on. Once again, this class is focused on this. It's focused right here. That's what we're focusing on. Inquiry level 1. Okay. So let me just clear that, and let's go back to the mouse. And let's get rid of this. Okay. So now we're going to be on the middle, which I have to annotate. Okay. So model the procedure. So I'm going to model the procedure. Now, what I might do is I might model it verbally, and I might have like the actual material in front of me to show them. I might bring up somebody. I might also put it on the board, like as an overhead. Okay, it might be projected on the board, the procedural steps. I might also ask students, can you summarize the procedural steps for me in your own words? I might say, why are we doing procedural step number 2? Okay. I also might give a worksheet out with that procedural steps on it. So what I'm trying to do is you just don't want to do it verbally unless the instructions are really simple. I'm going to be showing a lesson today where the instructions are so simple. I didn't even use an overhead. I didn't use a video projection. I didn't use a worksheet. But all that is good. Like you're reinforcing what you said with something written. And that's a big thing. At that point, when you're doing like, oh, I'm putting solution A into solution B, what do you ask for? You ask for predictions. That's really great. That's getting students prior knowledge out, right? Okay. That's the procedure. We're in the middle still. Now you have getters. So if you have a class of 30, you don't want 30 kids to come up to your desk. Okay. You know what? You know, because kids are kids and they'll fool around, right? They'll bump each other on the way up and blah, blah, blah. So you'll have, if you have a group of maybe 3 or 4, you'll assign one person as a getter. And so they get stuff and they put stuff away. Okay. So you want to think about when you're doing the procedure, you want to think about the material that you have. So if I have flashlights, if it's going to involve flashlights, my lesson, I can't afford 30 flashlights, but I could afford 6. Okay. So I'm going to make groups of maybe 4 or 5 with my flashlights. So I'm going to give roles to those folks. One might be the recorder. One might be the presenter. One might be the, the getter, but change it up. Every week you're changing those roles up. So if you don't give responsibilities to kids, then some people will be wallflowers and other people will just take control every single week. So you want to give responsibility. Depends on the equipment. In the lesson today, I have enough equipment for 30 students, so I am not giving roles. Okay, so the getters get the material, they pass out the material, and they now start to do the activity. It could be independently, depends on the materials. If I had my way, every student would work independently, but they would work independently by collecting data, and then they work as a group by sharing data and sharing problem solving. But because materials cost too much money, we have to work in groups. So decide what you're going to do in terms of your equipment. Now, I know you're going to be working, you're going to be team teaching a lesson with 2 other people over Zoom. So obviously, you don't really give roles because there's not really a group there. But in this class, we're going to be talking about Zoom, and we're also going to be talking about non-Zoom. So if it was a non-Zoom setting, and microscopes, I don't have a lot of microscopes. I'm going to form groups. I'm going to give responsibilities out. Okay. And so students will start doing this work. They'll start working and collecting data, and they'll be asking you questions. And your job is to go around the room and facilitate. So if they're like, oh, you might go around and say, are you reading the meniscus correctly? You're helping them with their technique, their procedure. You're really getting involved in that because you're going to help them collect quality data. Like, oh, I don't know how to measure. Oh, you come over and tell them how to measure using centimeters. You have to get really involved. Okay. Then it's a great time when they're working to erase the do now. Okay. And now everybody's pretty much done with their data. And people, like some people, maybe the presenter is starting to come to the board and they're going to put their data on the board so everybody can see it. And that is a really big deal. You want to make the data public so that everyone sees the pattern. Okay. So around this time when students are finished and they're starting to put stuff up on the board, you're collecting the materials. Why is collecting the materials really important in terms of management? Anybody? I can't see hands. Why is it important for management? What will kids do if
But
they're
nothing goes missing
not okay? Yeah, we're not so
or
worried about
spoiled
stealing
or
stuff, but
extra used.
I think kids will start fooling around with the materials. They'll start playing with the materials instead of looking at you or looking at the data. Okay, so get things into their hands and get things out of their hands. All right, and also guess what? When the bell rings, everything's cleaned up already. Okay, you don't have to run around and start getting all these things off people's desk and storing them and cleaning them. They're already put away and cleaned. So as people are putting up the data, like one person from each group, other people in the group are cleaning up. Okay, so let's do, and we're still in the middle, folks. We're still in the middle. So let's go
Professor,
down. Oh yeah, go ahead.
I have a question. When they're putting the data on the board and trying to identify the patterns, like sometimes it's difficult to see, right? Because there's so many data points. Do we put it on like an Excel graph and then see like correlation, or like how do students go about seeing these relationships, especially if there's like 30 different trials going on?
Right.
Or whatever it is.
Well, you're not gonna, first of all, you're not gonna have a lot of trials. And that's, so this is a lot less rigorous. You're not gonna have a lot of trials. They might only do it once or twice, and maybe they'll only get like one really good one that they believe in, but you're gonna pool all the data and then you might average it. So if you're getting, you might, if you're getting maybe an average from 6 groups, you'll have 6 pieces of data on the board, and that's very manageable. Okay, so you're not going to be flooded by the amount of data. And when you put it on the board, you have 2 ways to do it. You could use by, a whiteboard, or you could use an Excel spreadsheet if you want. Okay, and so students would be going up to your laptop and putting in data or telling you what their value was, and then you enter it. So it's not like 660, that course, where we're talking about a lot of data. All right, so good question. Anyone else? Let's see. I'm just going.
Yeah, so like
Go ahead.
sometimes like I've had labs where the teacher would just hand out a big piece of paper for us to like write down all of our results on, and then it all would be hung up like side by side, and then we would compare everyone's data together. Like, is that okay, or should we not try
Yes.
not to do that?
Well, you know what, you could pass out a worksheet where students are recording it. Once again, in 660, if you want to be rigorous, students make their own data tables, and that's more thinking. So you could have students make their own data tables in their worksheet. In their worksheet, you could have a blank space, or in the worksheet you could have a data table already made, but that data has to go up on the board. It has to be shown and made public. So guess what you do?
Yeah, that's
So
what I
that-
mean. Like,
so
and
that
instead
you
of
could read-
worksheet, it's like an oak tag. Like all the data is on oak tag for display.
I think that's fine if you don't have a big board. If you have a very limited board, I would do that. If I had a big board, I would just put everything up there. If it's a small board, you go with your route, which is fine. But the key thing is making data public and reaching a consensus. Okay, so I like that technique. There's multiple ways you can make data public. I think the best one is via a whiteboard, and the second one would be an Excel on a projector. And if you don't have any of that, then I think your idea would be great. So let's go down to after I'm going to clear this. So now data is organized onto, let's see, I just want to get, Okay. So here, data is organized into a table and made public on the board. At this point, consider making a graph or a bar chart. Once again, on the board or over Excel so that everyone could see it. Because, and this is the point, which is just the opposite of the procedure. When you were walking around the room and you're helping everybody with their technique, how to measure, you know, what to look at, you're helping them with, you know, not necessarily what it means, but you're helping them with like the instructions. Now this is the place where you have to shut up. Now this is the place when the data gets on the board, you can't say to kids, oh, don't we see a trend here? It's everything's going up. No, you want the kids to do that. You want the kids to see a pattern. The pattern might be a constancy. It might be something that's increasing, something that's decreasing, something that's maybe curved, like exponential relationship. So this is where you want to ask them, what do you see here? Can anyone tell me what they see? And then you want them to maybe, let's re-represent it. Can we re-represent this as a bar chart? Because it might bring out that pattern a little bit better. And so they do a nice bar chart normally, or a graph. And then you're saying, then you ask them, so what does this mean? Okay, so here comes a very interesting part, the vocabulary. So you might say, hey, you know, we're trying to figure out what this means. We need a special word. I think we need 2 key words. And I'm going to tell you these 2 key words. I'm going to write them on the board with a definition. I'm going to ask you guys, you know, do you think you know what the meaning is? If you don't, I'll help you out. But we're going to have a section of the board, maybe where the do now is erased, maybe on the other side. Anywhere that's free, you're going to have vocabulary. And you're going to mention 2 words. I don't want you to mention more than 3. But you have 1, 2, or 3 words that you want to introduce. And then you're going to say to the kids, after you defined them and you said, write them in your notebook, you're going to say, I want you to use these words to explain the data. Because we all have a consensus. It all went up. It all increased. But I want to ask you to answer the question, why did it increase? Using these 1, 2, or 3 words. And then you wait. You might have them write in their notebooks. You might have a group discussion, a pair or share, turn to your neighbor, talk, and then respond out loud. And then that's where you're kind of scaffolding them a little bit. You're kind of helping them in their explanations. That explanation that you get from them, that they're all thinking about and they're all talking about, and then you finally finalize, guess what? That's the answer to the aim. And then you have somebody come to the board and they're doing answer to the aim. And they draw a big box around it. You could have a big smiley face around it. You could have a big heart around it. You could have a big square. Like in physics, remember in physics, your answer was always in a box. But every other subject, every other science subject, we never did that. But it was always in a box. Put a big box around it. And the answer to the aim goes right below the aim. The aim is always there in the middle. So the answer to the aim is always in the middle. Okay. And so someone comes to the board, maybe 2 students come to the board. It could be a little bit tricky. And so, or sometimes students write the answer to the aim in their notebooks, and then you call on somebody to do it. You don't want to do it. You're really yourself. Okay. And you have them put it up. You put a big box around it, tell everyone to write it in their notebooks. And then you're almost at the end. We're at the end now. Answer to the aim is part of the end. You ask somebody to read the homework right here. And then you do a summative assessment. And in this methods 1 course, we're going to be asking students, we're going to be, I don't know, we're not going to do exit slips. We're going to be doing like a quick survey. We're going to ask 4 or 5 questions, and we're going to be just choosing certain students. But we're going to make it into a game. Because the reason is because students are kind of tested to death. And so you're going to have something really simple like Simon Says. So maybe you'll do some jumping jacks and you'll do this and do that. And you'll get someone who made a mistake and then you'll ask them, could you answer this question? Or you might ask them to pick someone else to answer a question. So you're spot checking. And that is your summative assessment. So that's the middle and the end, okay? What I just wanted to show you is that why we call it flex it, okay? It's where the vocabulary is. So here, the vocabulary right here, this comes after the activity. So in a way, the activity grows the vocabulary. What you could do it with flex it too, which is a few pages down. Let's go check it out. In flex it too, let's go to flex it too. It's right down here somewhere. Oh, here it is. Flex it too. Check out where the vocabulary is. It's right here. So in flex it too, the vocabulary comes before the activity. So now you're starting to see that this model has flexibility to it. There is a model 3, which actually is the same as the first model where the vocabulary comes after, but you do an application question right after the aim, you do this application question. And then there's even a model 4 where guess what? You do one vocabulary word before the activity and one after. So right now, I just want you to worry about model 1, but there are other models. There's like a couple more models, and it shifts the vocabulary and it also adds like an application question. So now you can start looking at parts and you can start moving them around. What I would like you guys to do when you guys graduate and on your own, I would like you to use one of these models. But I want to give you the total freedom to move parts around. Here's an example. How about if you have kids coming into your room and you're already set up? You don't need any extra time. Then don't do the do now. It's flexible. You don't have to do the do now, okay? You might want to move other pieces around that make sense to you. What I'm showing you today is that the vocabulary is an integral piece, and we could place it in different locations. We could place it before the activity. We could place it after the activity. Okay, we could do one word before and then one word after. So if the vocabulary is done like after the activity, it's almost as if the activity grows it. It almost as if the activity constructs it. If the vocabulary is done before, then the experiment is almost like an application. It's almost like an example of using those words. Very different, very different. Some people will argue one over the other, but I like to give you like the flexibility, as much flexibility as you can in your structure of your lesson. So this is all about structure. These are all pieces, beginning, middle, and end. The end is answer to the aim. Could someone read the homework? Let's have a fun summative assessment. That's the end. Beginning is the aim, do now, homework, motivational opening. The middle is the procedure, students doing the activity, collecting the materials and cleaning up, making the data public. What does the data mean? Maybe graph, is there a pattern in the data? Let's graph it to see that pattern. Can we explain it? What vocabulary do we use? That's the middle. Okay, so I'm throwing a lot at you. What we want to do now is let's look at an example. Let's look at a lesson that is like the first model, like Flex It 1. And then next week, let's do another example. And I'm going to show you an example like a Zoom lesson. Okay, so the example that I'm going to show today is a lesson I would actually do in front of you if we were at Hunter. Okay, and so it's a in-class lesson. It's not a Zoom lesson. It's in class and has these pieces that we went over today. It's model 1. Okay, and so I might stop the recording and saying, hey, we just finished this or we just finished that. We're focusing on the parts. Okay? We're focusing on the parts. I think next week we'll see, and then next week and the week after, we're going to be looking at different examples of the same structure of maybe Flex It 2 or Flex It 3, They're really, really similar with the exception of where the vocabulary is being moved. Okay. So we're going to be seeing multiple examples so that we're ready to try to mimic that structure. So the idea is pick out an activity, do it yourself to make sure it works, that you get good data. Okay. Because we don't have time to kind of like troubleshoot. We don't have time to like, let's retake data like scientists would do. And that's cool, but we're trying to get this thing done in 45 minutes. So you need to pick out an activity, see if it works. Is it simple equipment? So I don't have to have my, the people I'm working with spend a lot of money. Is it simple and safe? And then what we want to do is we want to work with our partner. Before we work with our audience, we want to work with our partner and go through it and who's doing what? Who's doing this section? Who's doing the do now? Who's doing the aim? Who's saying read the homework? Who is saying put the stuff up on the board? Who is saying collect the materials? So you're trying to go through that, divvy up the work, and then go through it as a dry rehearsal, and then you're ready for your two people that you're working with in your group, who's going to be your audience, and you're ready to make a date and do a Zoom connection, and you're going to record it. Okay. So right now is like we have to like kind of get those parts and make them part of us. We have to kind of infuse those ideas and know what these parts are. I think we know a lot of these parts, but we have to see it in action. We have to see kind of like, what exactly do we do? I'm going to go to stop share. And I'm going to ask you guys any questions. It's a lot of information, and I'm doing a lot of talking, but it's going to be handed over to you soon, where you're going to be doing the talking for the majority of the class. You're going to be doing your thing, and we're going to help you become a better teacher. Okay. This is only one way to teach science. But it's to me, the heart and soul, it's experimentation. Do we have any questions so far? Any questions so far? Okay. Let's give this a whirl. You're going to look at a lesson performed by me. Once again, if we were in Hunter, this is what you would say. Okay. So let's check it out. Share screen. Okay. I think we're ready for this. It's about 35 minutes. And this is what I'm asking you to do. I'm asking you to do a 35 to 45-minute lesson. This lesson has one vocabulary word. And at the end of this lesson, I want to know, hey, maybe, was that too simple or was that challenging enough? Okay. It's going to be a physics lesson. It's about refraction. Let's check it out.
Hey, good afternoon, class. We have a great lesson today. It's going to be very interesting. Before we begin, as I take attendance, can we all start doing the do now? So give me a minute, spend a minute on it, and write down your response, and we'll talk about it.
Okay, how can we improve this beginning? How can we improve this beginning? Anybody? I can't see hands.
We just started straight down to the business, so that is some conversation we held before. Like, what do you know? Any questions?
Okay, maybe from yesterday, but once again, the time is ticking. So I want to get right into the do now, but what would be good for literacy?
To build up, you read out. Sarita said to read it.
Yes, right? So have someone read it. Excellent. The more kids read, like reading the aim, reading the do now, reading the homework, the more they do that, the better, right? So this is the do now. So what I'm going to do is I'm going to go a little bit ahead because everyone's thinking a little bit and they're going to try to do it. Okay. I'll just go up about a minute and a half.
Okay. Denise, what is an example of one of your examples? Chameleon. Excellent. What's another example? Jesse? Manta rays or flounder. Okay, good. Good. Deborah, what was your,
You won't be able to hear a lot of the students. They're not mic'd up. The only person who's mic'd up is myself. So I try to repeat what they say.
example? Chameleon, popular. Omar. Walking stick. That's a great insect. How do they, like, first of all, why do they do this? We'll get into how, but why do they do this? Why are they able to camouflage themselves? Like, why do they camouflage themselves? Go ahead. Protect themselves from predators. Well, hunting for prey. Excellent. So protection and hunting. Now the question is, how does it work? And yesterday, we introduced two concepts. We talked about reflection and we talked about absorption. So let's just review a little bit. What is reflection? It has something to do with light. Remember, we're in the chapter on light. So reflection, what is that? What does that mean? Omar? Okay. Deborah, could you just repeat what Omar said? When light bounces off something. Excellent. How do we, what's an example of reflection in our lives? How do we know light bounces off something? Another person. Something in our environment, in our lives that light bounces off. How do we know it bounces off? Okay. Yeah, you could see yourself in in a pool of water, right? What about a mirror? So we know we have evidence, physical evidence that light bounces off a surface. What about absorption? What is that? Remember from yesterday, absorption. Reflection is the bouncing off of light. Absorption is the, yeah, it takes in, the taking in of light. How do you know something takes in light? What's an effect? An effect. Okay, hands up. I need a hand. I need a hand. Okay, Tony. It becomes dark, hot? Dark. Dark. Okay. Okay. What do you mean by dark? Like, what was the example you're thinking about in your mind? Okay. I was thinking more along the lines of if something gets hot, you know, it's taking in that light energy. Okay, so that's some good evidence. But thank you, thank you. So absorption, reflection. That's what we did yesterday. And what I want to do is I want to think about living organisms. And I'm very interested in, like, how does it work in terms of different animals that light reflects off or light absorbs. So let's look at some animals. People brought up the walking stick. People brought up the chameleon. There's a couple of other ones that are very interesting too. And I looked up at Google Images and I found a couple of things that that are not. I didn't use a chameleon or a walking stick, but I have a few other ones. So we'll just take a look at that in a few seconds. And one thing is that if we're talking about foreground and background, how is an animal able to camouflage himself? We're talking about foreground and background. So the shape and the color of the animal is similar to the background, right? And so if we're talking about in terms of reflecting light, do you think the object, the animal, and the background, do you think they reflect light in a similar way or in a different way? In a similar way. What about absorption? Do you think they absorb light in a similar way? The animal and the background? Right, they absorb light and they reflect light in similar ways. That's why you can't really see them so well. So let's look at, Tony, can you just hit that one of those lights so we can get a better picture here? Great. So do you see the animal, folks? Yes. What is that? Frog. Good. Where's the animal on this one? On the right, what is it? Kind of like a fox. It looks like a fox, gray fox. Oh, well, how about this one? The lion. And where is it? On the right or left? Left. Uh-oh, it's getting a little bit harder. Where is this one? Does anyone want to come up and point to it if they see it? Kind of hard? You need anyone think they got it? Come on up, come on, show me. Yes. And do you know what it could be? It's a deer. And in the eyes around here, it's difficult to see, but there's a deer here.
Yeah, I think it's actually a wolf, but
I think if we had better lighting, it might come out. Let's get another one. How about that? Anyone see anything there? What do you see? Yeah, it's actually a salamander. And this, once again, it's reflecting and absorbing light in a very similar way to the leaves. So that's why we have a hard time differentiating it. It doesn't stand out. So this absorbs very similar to that. So here we have the last one. What about that one? Okay, someone said something. Raise your hand. Who wants to go up? Oh, we got. Jesse has good eyes. Okay, anyone want? Omar, you want to try it? Okay. Right. What do you think that is? Tarantula, spider. Right. Okay. Good job. Let me turn that off. Could you have Tony? Could you hit the light specs? So we have the animal on the foreground. We have leaves in the background. So the animal looks like a leaf. So it's going to reflect the light. The light's going to bounce off it in a very similar way. Light's going to be taken in by the object in a very similar way. That's why it's very hard to see, to differentiate between the object and the animal and the background and the scenery, okay, and the environment. So that's how to explain it in physics speak, reflection and absorption. So we learned about that yesterday. Now, today, what about if the living organism is transparent? Denise, could you read the aim for me?
If they can't, how can they do it?
So what do you mean a transparent organism? Well, I got a few pictures. Right here, everyone's going to look at them in their desk. And this is a transparent organism that's found in the very depths of the ocean. So let's take, I think I have, let's see, one, I think two of them. Check them out. Check them out. So what does transparent mean? And I think we need to write that word down.
Okay, so so I need space. I need some board space. So getting rid of the do now is a great thing to do. It just opens up the board a lot.
So what do you,
And so transparent, this is not like an important science concept, but you kind of have to know it for this lesson. So I'm kind of saving the key science word that I really want to teach until after the activity.
transparent means? What do you think transparent means? Go ahead. Right. So something you can see through. So what about in terms of light? I guess that's what we're focused on. Light can do what? Go through. Go through, right? The light can pass through an object. Okay. So now what we're going to do is select those pictures. Just have those back again. So I don't have transparent organisms for you folks. I can't go to the depths of the ocean and bring these things up. But what's
So now I'm entering the middle, right? So once I kind of got that vocabulary word, that's not really the most important thing in the lesson, but now I'm starting to like, what are we going to do today? What activity are we going to do? Now I'm getting into the middle. So I had the aim, do now, and you can see the homework on the far right. And the motivational opening, that was those animals that were difficult to see in the pictures. Okay. And also the pictures of the transparent living organisms at these great depths in the ocean. That was my motivational opening. It also was connected to camouflage, which kids really enjoy. I think everyone enjoys. It's kind of fascinating. So let's see what the middle is about.
I love to do is to model. So this is my transparent organism. A lot of those things were like jellyfish. They had like seawater in it. So my oil is the seawater because it's kind of, jellyfish are kind of surrounded by this water and kind of has some of that liquid in it too. So here you have the transparent living organism. All right. That's my model. Here's my ocean water. Okay. So those are my two things. I want everybody to come up and get this. I want to model what you have to do. You're gonna get this test tube and you're going to put it into here, but you're not going to do it until I count. I'm gonna count 1, 2, 3, and we're all gonna do it together. And then we're gonna make some observations. What would be anyone's prediction? I want to put this into here. What is gonna happen? Explosion? What's gonna happen? Prediction. Omar? Who heard that? Denise, can you say what? It might look like the test tube disappears. Why would you say that? The similar colors? Okay. So normally you put a piece of glass in some liquid, it disappears. There's something to the light. Okay, so that's your theory. What's another prediction? What do you think is going to happen? Okay, Denise? You'll be able to see right through it. Okay, and why do you say that? A little louder? Transparent, all right. Jesse, you had your hand up. What do you think is going to happen?
Bigger.
Okay, and why do you say that?
Just because the way the light moves through the water and then
Okay, let's see what happens. So everyone can come up and get this, but don't put the test tube into the cup until I give you the signal, all right? So Deborah, this is your setup.
Thank you.
It might be a little gooey, but I got some soap and things. So just take one of these, take one of those. take one of those. Everyone gets their own cup. Okay, and do you need anyone else? Okay, great. So now, don't put it in yet, okay? Want to make some observations? Take a second, make some observations. You can write your observations down in your notebook. What do you see? Okay. On the count of 3, I'm going to start. You could just put it into it. 1, 2, 3. Go ahead, blast off. I need some observations. What do you guys see or don't see? Okay, Tony.
It reminds me of the pictures you passed out where you can see straight through it. So transparent.
Okay, you can see right through it, but so when you put the test tube in, what happened?
Well, it kind of disappeared. Like, oh my.
Right, like it disappeared from sight. We know it's there, but it disappeared from sight. Anyone else can back up what Tony's observation was? Same observation? Deborah, you're shaking your head? All right. And what happens when you pull it out? Right. Oh my God. So we need to explain this phenomena. And let's see, does reflection really help us? That's like something bounces off, the light bounces off this object. Is it like a mirror? Something kind of like light bounces off it, or is it like some of the animals that we saw? So it's kind of, what color do we see? What color do we see? What color is the oil? Yellow. So if light reflects, so here's we have light here. Here's our test tube. So light has how many different wavelengths, we'll say? Main wavelengths, the main components of light. Okay, what are they? Red, so the spectrum, right? The spectrum. So red, orange, yellow, green, blue, and violet. Boy, G-bib. All the light hits this, but we see kind of yellowish. That means a lot of stuff has to be absorbed. And the color that goes back to our eyes is what? Yellow, we see yellow. So we could explain this in terms of some colors are absorbed and some colors are reflected. Some light, wavelengths of light are absorbed and some wavelengths are reflected. That's one way to explain it, but this is a transparent organism where light passes through. You can see right through it. So we need to come up with another term about light, because light is about taking in, an object takes in that light, or it bounces off. But now we're talking about transparent where the light passes through. We need another term. We need a new concept, a new vocabulary item that could explain light passing through. And that word is refraction. What does refraction mean? Did anyone ever hear that before? Refraction is the bending of light. So when light goes through a medium, it kind of bends. It changes. Okay, once again, foreground and background. We have the test tube and we have the background is the oil. We have the organism and we have the environment. So we know about reflection and absorption, but what about refraction? Do they refract light in similar ways or do they reflect light in different ways? When you put that, when it's in the oil. What do you guys think? Point? In a similar way, in other words, if light goes through it and it bends that light, the glass bends it of the test tube and the oil bends it, but you can't differentiate between the two, that means it bends light in a very similar way. It bends light in a very similar way. So that's our concept. Let's think about going back to the aim. Can transparent living organisms survive by camouflaging? Well, we could do a quick little extension. So I want you to bring all your gear up, all your setup right here. Okay.
So because this activity was so short, just like put a test tube in some oil, I really kind of segued into like something more quantitative. Okay, so I want you guys to try to come up with something quantitative because that will allow students to maybe make a bar graph or graph, and that's the problems they have in college. They have difficulty graphing. They have difficulty analyzing data through the graphs. And so that's really what I'm trying to do is I got this qualitative experiment, like, okay, the test tube goes in the oil, it disappears, but what about something that's measurable? What's something about with numbers that's quantifiable? And so when experiments are quantifiable, they're richer. They allow students to combine math and science, which is a huge goal of science ed standards. So let's just check this out.
And we're going to try to answer that first part of the aim. Okay. Everyone come on up. Okay. And we're gonna I want you guys a little bit to the right, a little bit to the left. Okay. So here, what we're gonna do is we're just going to put these guys in here. Get rid of these for a second. So we're gonna put these here. I'm gonna I have one more. Right now, I have a dime. I have a dime. I'm gonna place that in a cup. One of you guys are gonna be a predator. And I'm gonna have you go there and one of you guys are gonna place this in a cup. We're gonna come over and find out how long it takes for you to find this dime. But I'm also gonna put a organism, and it's the glass. It's the same glass as the test tube. And they're about the same size. I'm gonna put that in a cup. You have to find both. All right? So who wants to be the predator? I need a predator. Yeah, okay. You're the predator. You have to go over there for a second. Hey, Tony, you put these wherever you want to put them. All right? Put whatever cup you want to put them in. All right? Okay. Now, Deb, I want you to be the timekeeper. Do you have a watch? Does anyone have a watch? Okay. Set that up. I mean, I have a watch here. You want to use my watch? Hey, Deborah, you use one watch. Okay. When she gets close to you, when I say begin, you look at the seconds and you have to record the seconds that it takes to find each object. All right. So we'll just work on it. Hopefully we'll get to another trial. We're gonna do another trial. So no pressure. Okay. Okay, we're gonna be at that spot, so I'm gonna say just walk over. So begin. Okay, come on over. And find your dime and your.
The dime.
Okay.
And wait, touch one.
Sure. Okay.
5 seconds for the dime.
5 seconds here.
25 seconds for the glass.
Okay. So we have time and seconds for the, and how many seconds it needs does it pass to find the glass and the dime? 5 and 25. But that's just one trial. I want to be positive. I need another predator. Oh, yep. Oh, sorry. Thank you. Thank you very much. Glass was 25 seconds and the dime was 5. Thank you. Okay. Who wants to be another predator? Good. Okay. Go back to your area, your predator area. Okay. Now, who needs? Okay, we're going to. Which one is? Where is this one? Okay. We're just gonna switch it. So, Eleanor, you just place these wherever you want to place them. All right. Okay. No. Okay. So, timekeeper, are you ready? Okay. Okay, Tony, begin. Come on over.
And here's one. And the other.
All right.
17 for the black and for the
Good. Well, thank you very much. Everyone sit down and relax. Thank you. Now, let's look at the data. What does that data mean? How can we interpret that data? How can we interpret that data? Hand. We got one hand. We got 3. I'm waiting for all the hands to come up. Okay, good. Okay, Deborah.
it's the a lot longer by the black.
And what does the glass represent? Tony? Okay. Well, that's the concept behind it, but what does it's a model, remember? Because, okay, Eleanor? Yes, a transparent organism. That's what the glass represents. The dime represents a non-transparent, something that is opaque. Opaque means light cannot pass through it. All right. So we have these 2 organisms. Which organism do you think is going to survive the longest based on this data? Denise? Right, the glass, the transparent organism. So let's look at the aim. Can transparent living organisms survive by camouflaging them?
Okay, so at this point, I had the data on the board to make it public. There wasn't a lot of data. It would have been nice if I did a bar chart, which I basically added after doing this video. This video was done a couple of years ago. So a bar chart would have been really nice. But that idea is that I'm not telling the students that there's a trend. I'm asking questions. It's very different about all the instructions I was giving them, where I was helping them and, you have to do this, you have to do this, and you have to do that. I'm asking questions now when I'm looking at the data. So now I want to try to hook up the vocabulary and the data to the aim.
Oh, what do you think the answer to that is? Yes. Now, if they can, how can they do this? How can they do this? Now, Tony brought up the idea of refraction. To explain, can you explain that? Can you elaborate on that?
To the beginning of light. So when the light goes through the glass ground, go to astral organism.
Right, so it bends light in a similar or different way?
Similar way.
Yeah, right, in a similar way. So when light passes through the organism and through the environment, it bends in a very similar way. You can't differentiate. The background is very similar to the foreground. Excellent. So yes, they can. How can they do this? Okay, can someone read that? Denise, you want to read that? The answer to the AM?
Yes, the transparent organism plus its environment, then light refracts in very similar.
It refracts light. It bends light in very similar ways.
And so it would be better if I had a student to come up to the board and they put that in there. That'd be better. But still, you can do it as a teacher.
Write that down in their notebooks. The answer. We learned something today.
Okay, we're at the
I also
ending.
want you to copy down the homework.
Good.
But first, let's read the homework. Hey, Eleanor, could you read the homework out loud, please, for everyone?
A transparency organism does they complete function using crystal health and survival.
Okay, great.
Okay, so one thing you have to think about is when you're having students answer the aim and to think about it. Once again, you could do it in a different ways. You could work as a pair. You could have one student, every student to write it in their notebook about what they think the answer is. You could have share outs. You could have students come to the board, but there's going to be some wait time that you have to put in, some wait time. And where students are thinking about answering that question. Don't move on to the homework and then move back to the aim, because you're refocusing students. What you want to do is you want them to keep the focus on the aim. So once you're complete, once that aim is complete, and it might take a few minutes for kids to process it, then when it's a fully complete and you have a big box around it, then move to the homework. What I've seen a lot is that some students are kind of like feel uncomfortable about the time. And so they mention like, oh, could someone read the homework? And then they go back to the aim. That refocusing is not good cognitively, okay? So finish the aim, and it might take a little while to think about it, and then have someone read the homework. And now the last part, the fun summative assessment.
Oh, we all know we're at that point. The lesson is pretty much over. We want to assess and evaluate if you understood something. So I'm gonna have a couple of questions for you, and we're gonna have fun doing this. So this is called last student standing. Last student standing. So everyone stand up. Okay. Make sure there's no objects. I don't want you to hurt yourself. It's a physical activity. I want you to, when I say on the count of 3, I want everybody to sit. The last person who sits has to either answer a question, or I might want you to ask someone else a question. So it could be a good thing, it could be a bad thing. All right. 1, 2, 3. Deborah. Okay, Deborah, you got the first question. What does refraction mean? What do you guys think? I need a confirmation. Yes or no? Is that correct? Yes. Excellent. Everyone stand up. 1, 2. 3. Oh, I think Omar, I'm going to let you choose somebody. And this is the question. Give an example of refraction that we observed in class. Give an example. Who do you want to ask? Okay, Eleanor, give an example of refraction that we observed in class.
Putting a piece of glass inside the oil.
Right, in the glass, inside the oil. What did the glass represent again?
Or the oil,
Organism. And what did the oil represent? The environment, the ocean. All right, everyone stand up. A couple more. 3. Okay, Omar, you're getting the question. Explain how the test tube filled with oil can become invisible. So you have the test tube filled with oil and it was placed in oil. How did that become invisible?
They both refract the light in a similar way, so you don't see a difference.
Right. And what about in terms of absorption and reflection?
They absorb different light colors and
Right. But mostly we're focusing because they're transparent. There's some absorption going on, there's some reflection, but it's mostly refraction because it's transparent. Excellent. One more. Come on up. 1, 2, 3. Oh, Tony. Tony, explain in terms of refraction how transparent underwater. Oh no, here's a good one. I want to do this one. This is a good one. Test tube filled with water into a cup of water. What do you see, Tony? What do you see?
I see the test tube in the cup of water.
Why do you see the test tube in terms of refraction? Why do you see it?
The water in the test tube isn't bending the light same as the water in the cup.
Right. You have glass and you have water, and they're not bending the light in a similar way. Therefore, the foreground, the organism, and the background, the environment, are discernible. They're not camouflaged very well because their light is being bent in different ways. Great, excellent job. Okay. Well, you guys did a great job. I will see you tomorrow with another excellent lesson.
Okay. Thanks for viewing this. It's so much better in person, and it's kind of a bummer that we're on Zoom, but it is what it is. But it's really amazing when you could experience all this. And in your lessons, I normally sit in the back when you guys do your lessons, and I record everything, and they're amazing, and they're really interesting. And so a lot of you guys, I guess here's a question. Have you guys experienced a lesson like this? Have you guys experienced a lesson like this where data is made public, where you're looking for patterns, an aim is always being answered, it's in the middle, where maybe it's fun summative assessment? Have you guys had science classes like this?
Does math count or no math? I've done something similar in like statistics.
Okay. I was thinking more about science though, because it's a physical event that we're examining.
I have.
Okay, good. What grade did you have it? Did you have most of it like this, or only a few grades?
It was a mixture. I'm thinking more like my last 2 years of high school, where we were more focused on biology, chemistry, and physics if we were in the science stream.
Okay.
And most of our lessons were accompanied with labs.
Hey, okay, here's a question. Is that a British system or a Caribbean system, or is it the US?
The British system.
Okay.
Or in the Caribbean. It was in the Caribbean, yeah.
Okay. The Caribbean is made up of been colonized by different countries, but some of them is British or English, right? And the English really value experimentation. You learn science through experimentation, not through concepts and word problems. So Kavita, you're really fortunate to get a British science experience as your background. That's amazing.
Thank you.
Okay.
Yeah, we had labs every week
Yeah,
for our
yeah.
last 2 years of high school.
Okay. Has anyone have like that aim being the center of the entire lesson? Has anyone had that experience? The aim, and then when you answer the aim, it's connected very explicitly. Yeah, I never was taught this, folks. This was not something that I experienced at all. Okay. And so we're trying, like for some of you guys, this is brand new. This is like, I was never taught this. Other folks are like a little bit. Over the years, it seems to me that school education, science education is getting better, and we're starting to approach this type of thing where students are doing an activity, but you're connecting the vocabulary to data to try to answer an aim. The answer to the aim is always the drive of the entire lesson. Okay. And so those are the pieces, the beginning, middle, and end. Now you could say, well, Dr. D, you kind of did two activities. Well, I kind of did like a qualitative one, but I wanted to kind of do something where I could show you that I can make a qualitative into a quantitative. I want you guys to focus on like just one activity, one where it's quantitative. That's what I'm really hoping for. Sure, you could do qualitative and you could make a data table and maybe you could try to make them like high, low, something like that. But you're trying to think about, can I do a graph? Can I get some values, measurements? Because you're getting more out of the activity. Okay. So this is what we're aiming for. But right now, you might be like, well, this is the first pass. As we do the next few weeks, you're going to see more and more examples of this. And then I'm going to be showing you like a Zoom version of this. But once again, like if you guys in my classroom, we would be doing this and you guys would be like, you'd hold that test tube and you see it disappear. It's like, wow. There's a whole emotive, affective domain. There's this emotional component to science and investigating the physical world. That's really hard to get over video. It's really hard to get that. But we're going to do the best we can. Okay. What kind of questions do you have about that lesson? What do you think, you might do something different? Why are you doing this, Dr. D? What, I didn't know what part this was under. Do you have any questions like that? Wasim, do you have a question?
Yeah, a little. So like I noticed whenever you would go to the board, there would always be like kind of like these quiet periods where like there was absolute silence in the room. Like, was that deliberate for like information processing? Or like could it have been filled by maybe you reading what you were writing or something like that?
I think you have to be very aware of like giving wait time. And so, for students to process, when you have a question, you should wait. And I'm talking about maybe 3 seconds, 1, 2, 3. That's a long time when you're at the board or you're in the classroom. So I think one of the components to good teaching is after you ask a question, wait. Okay. There were a couple of nice little things in that lesson. Like for example, and I could have done it more. It's like, asking one student to paraphrase what the other student said. That's really good for like, cultivating listening skills. Another thing is read this and read that. Another one is always write this in your book. Okay, kids, write this in your notebook. Okay, kids, because you and I, we're all used to doing that. We're used to writing, having really good notes. But there's a lot of students who don't bring pens to the class. Really, they don't bring pens to the class. I mean, I was like absolutely shocked. I was like, what? And so what I tell you guys is, go buy a big group of those golf club, the golfing pencils. They're really tiny. And so students really don't like it. So if you gave them good pens, they would just walk out of the room with them. So with pencils, they're able to take notes, but they know that next time they'd rather have a pen. So asking them, put this in your notebook, what did can you paraphrase what this person said? things like that. So there's a nice like little things that you can do in the middle that are not even in my structure. Just something that we kind of like get used to doing. Okay. Could you write this in your notebook? And then what about great job? Excellent. Try to be positive. If I could do that lesson again, I'd probably do 3 or 4 things differently. I'd put a graph up there. I'd be more positive. Okay. I was trying to use my hands. I was trying to walk around the room a little bit. Okay. I was trying to inflect my voice. That's what we learned from that video in terms of that. You know, I just didn't stay close to the board. Okay. I want to show you something that's going to kind of freaks me out. And I think it's going to freak you out. And so I'm going to go for that. And I want to show you this 2 minutes of this thing. Can everyone see this? Yes. Okay, let me start this. Okay.
Inside of nucleus, around the nucleus, moving constantly are electrons. Region around the nucleus is occupied by electrons, carry all the negative charge of the atom, but contain very little of the atom's mass. So it's very, it's really very light. Really, they don't make up the mass. Okay, photons and neutrons make up the mass of the atom, and they're called nucleon. The nucleus of the atom consists of 2 types of particles, photons and neutrons, together known as a nucleon. Did anyone ever hear this before? No. Nuclear.
Okay. What? I'm going to stop share. I can't see it. I can't watch this really much.
That's what I had in a class.
Okay. Did you guys, who was that person?
That was you.
Yeah, that was me in 1985. Okay. So what did you see? You only saw 35 seconds. It goes on for 5 minutes. I can't handle it. But what did you see?
There is no inquiry. There is no question. There is no interaction. Just a
Right.
lecture.
So very few questions. Well, okay, more. Give me more observations. Very few questions. Good.
You were reading off the board, basically. You weren't really looking at the class.
Right. It was like dominated by notes. So good teaching was someone who had good notes. What else?
I guess the
You
body
did not
language.
The body
Sorry.
language? Talk to me about the body language.
Oh, you just looked very uncomfortable up there.
Yeah. Right. There was like no animation whatsoever. Okay. What else?
I was gonna say neither you nor the students look very engaged. It was just like
Yes.
going
So,
through a routine.
But back then, a good teacher was someone who produced good notes and could explain something. So that was my student teaching, folks. And so I look at that person and I can't recognize who that person was. Okay. I transformed, I changed as a teacher. You could see it right in front of your eyes, these 2 videos, right? And I could play the when I was in 1985, whatever it was, or 87, whatever, I could play that, longer, but it's just like 2 people. It's like, I knew that guy somewhere in the past, something familiar about that person. And that's the kind of transformation that I want you guys to think about. I want you to think about, how you can be maybe someone very different, someone who's going to have structure, but it's going to be centered at the student, where you're going to be enthusiastic. You're going to show that you're interested, and that you're going to try to have them create meaning. Like I just had kids read the stuff, or I read the stuff, but you saw the lesson about refraction. How many times did I ask folks, so how do you explain this transparent organism? What's going on here? I must have done it 5 or 6 times, so that kids are internalizing it. They're thinking about it, because the kids won't get it on the first pass. They need multiple experiences, multiple questions. So to me, this course is really about transforming, the teacher, the person that the way you were taught, all right, and into maybe something that transform into something that you really are really proud of being. Okay, and so there's going to be, you have about 15 years of experience of being a science student. You've seen all this teaching. Then you have your peers. You're going to be going to school and you're seeing all these peers and how they teach. The last little piece is what you experience at Hunter. That is going to be the smallest amount of time that's going to influence you. Your past is going to be a huge influencer. The people you work with year after year is going to be a big influencer. And then you have this little sliver of what you learned at Hunter. You have to think about what area you want to influence yourself. What who are you going to listen to try to be the teacher you want to be? It could be a combination of your past and now in Hunter. It could be this experience, this little sliver of time that you have Hunter, you're at Hunter trying to figure out what kind of teacher you want to be. Okay. And so what I'm saying to you is you can make some great changes. I think I have, from that person who's stuck up at the board, who's like non-animated, who's reading stuff off the board, to somebody who's trying to engage learners, who's in their space, using voice, using hands, trying to keep it simple, keep it straightforward, where I'm not overdoing it. You saw that board, all those concepts flooded. It was, the whole board was covered. Look at the board of the lesson that I put on. Yes, we did have notes. Notes are valuable, but look at the board space. It wasn't too much and it wasn't too little. Okay, so I'm really asking you guys, keep an open mind. Think about the transformation you want to be. Think about the teacher you want to be, and let Hunter, let this experience, this small sliver of your life affect you. Okay, so next week we're going to look at just more examples. We're going to try to ingrain it, try to get it into our system about what we have to do. I am definitely going to be showing you guys some Zoom stuff. So in other words, we're almost going to take what we saw today and kind of convert it to a Zoom experience to get a better idea of what we have to do when we go into our own groups. So I think right now, there's no really formal homework. I would start to look at what activity do you want to do with your partner? But look at my activity, really simple. A cup, a test tube, and Wesson oil. And that was it. Okay. I also had a dime. That was it. So try to keep things really simple. If you can't come up with one, you could always ask me and I could suggest certain activities. But this time is really great because you want to explore the internet. You want to look out and see what's good in your area. And you might come across 5 things, but you'll only choose one for this class. But you might come across other things that you want to create in folders that you will use when you become a teacher, a full-time teacher. So this is what I did. When I was younger, I went to the library, we had no internet, and I went under like the magazines, the journals. Like it would be it's called The Science Teacher it's published by NSTA, the National Science Teachers Association. And I would look through all the new ones, right? And I was like, oh, that looks like a good activity. I'd Xerox it off and I'd have a filing system of all these different activities you could do for each like specific unit. So use this time to just explore the internet, find out what's out there, pick out stuff, Xerox stuff, download stuff, but find something that you and your partner wants to do. Okay, keep it simple. I only used one concept, and to me, I think that was challenging enough. Refraction, trying to explain that physical event with the word refraction. I thought, those kids were, those students were like you. And it wasn't just like, oh, I'm bored, I'm falling asleep. They were like processing. So keep it simple to 1 to 3 new concepts to explain a physical phenomena. All right. That's kind of like the homework that we have to do. We're headed in the right direction. Once again, I really look forward to this class to see what you have come up with and where I could shut up. All right. So I've got a few more days of this, we've got a few more times, but we're moving in the right direction. we went from, we're beyond the lesson plan, we're into the lesson itself, and we're going to be ready for, we're just going to be looking at more examples and kind of fleshing things out so that we can follow the steps. That's all I'm asking. I want you to do it. Aim, do now, homework, motivational opening, do the body, and then do the ending. Answer to the aim. Someone please read the homework, and then do a fun summative assessment. Do those parts. Okay, do those parts. One part at a time. Do not look at the entire thing and feel like you're overloaded. One little part at a time. So it's all about structure, but it's also, remember, it's a script. But we know that there's a lot of terrible movies, right? You have to have a good actor or actress and a good script. You have to bring your knowledge and your motivation and your excitement and your animation, your energy to bear. Okay, so the script is really powerful, but it cannot do it by itself. It needs a teacher who is committed to that lesson. All right. Okay, so we're going to be we're leaving today. I'm just going to do attendance. But before I do attendance, does anyone have any questions about what we did today? We did a lot. We did a lot. Okay, we're learning through video. It's the best we can do. Okay, once I call your name out, you could log off unless you want to stay on and talk about any topic whatsoever. Okay. Veronica, I got you, right? Where's Veronica? Veronica, okay,
Yeah,
I got you.
here.
Good. Stacy. Where's Stacy? Stacy. Stacy's not here. Okay. Dimitri, I saw you. Good.
Yep.
Jonathan. Who's Jonathan? Okay. Wasim, I have you. Good. Brady, I got you. I think okay. There you are in front of my screen. Samuel, I saw you. Good. Have a good night. Melissa, where's Melissa? Melissa, there you are. Okay. Katerina,